So the material comes into the black hole, falls onto the black hole. If you have your accretion disk, roughly speaking, there's a jet perpendicular to the accretion disk. During the initial stages of the outburst, there's a jet which is like one continuous long burp. It's just a jet coming out, sort of maybe imagine your water hose, you turn your water hose on, and your water hose is coming out, except this is probably more like a cone of material coming out. And it's a very, very narrow cone of material coming out in both directions perpendicular to the disk. So that's what we call a compact steady jet. We call it a compact jet because it turns out that with all our best instruments, we can't really see the structure of this too well as we go down the jet. We can tell some of it, but we can't tell it in detail. Now it turns out that black holes have another type of jet behavior, and they undergo a switch where all of a sudden they go from this sort of nice little compact steady jet to a sudden burst where instead of the compact steady jet, that compact steady jet seems to be gone, and you get these blobs of material that go out with time. So these blobs of material are jet ejectas. In the Canadian press, we call these things black hole burps. The Americans call them black hole bullets. One of the reasons why they're called bullets, perhaps, in the American press, is that we talk about the trajectory that these things have. And so these objects go in a straight line. And that trajectory is called a ballistic trajectory. And so it is not a small stretch to go from a ballistic trajectory to a black hole bullet. The particular press release officer at the University of Alberta was not a fan of that particular description and went with burps. And I think it's a wonderful analogy because we can talk about the feasting that the black hole is doing and relating it to their burps, although they have different types of burps. Some are sort of your short staccato burps, and some of them are these long continuous burps.